Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to talk about Azure Cosmos DB and we are going to create a Cosmos DB in the Azure portal. I'm going to tell you about the various key features of Cosmos DB. As you all know that Cosmos DB is not like your regular database. So that is why there are few key concepts that are related to Azure Cosmos DB. We are going to see that. We are going to see how we can edit and manage the databases in Cosmos DB. We are going to query the data with SQL, although it is a NoSQL database, but still we can query it using SQL. I'll show you how we can do that. We are going to talk about different consistency levels, different consistency settings in the Cosmos DB, and we are going to talk about indexing as well. So let's go ahead and see what are the key features of Cosmos DB, what exactly the Cosmos DB is. So when you talk about Azure Cosmos DB, it is definitely a fully managed, NoSQL database. So when I say a fully managed NoSQL database, it is essentially, it has two key features. One is, your its global distribution. It is a globally distributed database. Plus, it has a multi-master replication, as well as it has low latency operations. So whenever you have these three requirements, in that case, you can definitely go ahead and use Azure Cosmos DB. It is not essentially used for your any ELT operations. It is mostly used for applications like your IoT applications because of its low latency and the global distribution that it has. When I say global distribution, it essentially means that the data that is written in Cosmos DB, that is replicated across multiple regions. And it has a very low latency as well. So when I say low latency, the response is actually in milliseconds. So that definitely holds very good for your IoT applications. So that is what your Azure Cosmos database is. So this diagram which you see on the screen right now, it actually shows you how the data can be replicated and the data is connected as well. Also, Azure Cosmos DB has many APIs. So it has a SQL API which we are going to use today. We are going to query the data for using SQL API. If you are migrating from MongoDB, in that case, it has an API for MongoDB. And in case you are trying to develop a graph database, it has a Gremlin API. In fact, I think Cosmos DB is only PaaS service that has Gremlin API or a graph database. Similarly, you have your Cassandra, or in case you are trying to migrate the data from Azure Table Storage, in that case, you have the API for Azure Table Storage as well. So now let's move ahead to the portal, and then will actually go ahead and we will create Azure Cosmos DB. So I'll go to the previous option, to the home option. Okay. So guys, right now what you can see on my screen is Azure portal. If you have been watching my previous videos, you must already be having an Azure account created. And let's go ahead and select Azure Cosmos DB over here. Now, once you select it, let's go ahead, click on create. Now, once you click on create, you can actually see these API options which we have been discussing. So I'll go and select the SQL API right now. And I don't have a resource group right now. So let's create a resource group named as RG Bhavna 33. Okay, it already exists. And let's write 44. And let's click on OK. And similarly, I have to provide an account name. Let me provide an account name as YT Bhavna 3344. And then we are required to choose from location and capacity mode. Now here are the key concepts involved. So when I talk about capacity mode, we have to provision throughput and serverless. What it essentially means. So whenever you're working with Cosmos DB, you are actually being charged for two things. One is the storage and second is the processing that you use, right? And processing is defined in terms of RUs. RUs are nothing but the request units. So if you see this line over here, you can see RUs per second, right? So this RU per second is nothing but you can think it as capacity that you are taking from Cosmos DB to do your work, right? So that is defined in terms of request unit. I'll quickly go back to my PPT to explain you this. Now what you can see on the screen right now is the request unit. So request unit is the combination of memory that you're trying to use, the CPU, and the input output operations that you are trying to perform. Now these request units, so let's say you're trying to perform a read query, right? So that will require some processing power, and then your Cosmos DB will fetch some request units for you, and it will apply for your read operations. So you actually pay for RUs over here. Now when I'm saying you pay for RUs, how the pay is defined for RUs? So it depends on the count of the data. So let's say you are reading thousands of the rows, then the number of RUs will increase. It depends on the process that you are trying to use, trying to do. Let's say you are trying to create a stored procedure, a trigger. Now in that case, the number of RUs will increase, and your charge will also increase. It also depends on you know your indexing. So by default, it is indexed, but in case you are trying to do any additional indexing, in that case itself, you have to pay for additional indexing as well. Now, similarly for the data consistency, I will talk in detail about data consistency. It is a very important concept. So for the data consistency, you pay in RUs. So why it is essentially used for IoT applications, not for your ETL operations, is because see, it is quite evident that in case you're trying to do any insert, upsert, delete, or you're trying to run a stored procedure, you are going to be heavily paying for RUs, right? So and that is not something that you want. So that is the reason it is not essentially used for any ETL operations. It is only used for IoT applications where you want low latency and high throughput is what is required. Now, basically, I'll go back to the portal again. Now, what you see over here is provision, throughput, and serverless. Now, what is this capacity mode? I have explained you about RUs, the concept of RUs, but what is capacity mode? Capacity mode is essentially how you retrieve the RUs from Cosmos DB. So, RU concept is clear. Now, how you receive RUs from Cosmos DB is your capacity mode. So, now let's say you are pretty much aware that yes, this is how my data load is going to look like. So let's say you are pretty sure that these are the operations that I'm going to perform. This will be my data load. So you by default you define that you are going to use 5000 RUs per second. So you ask Cosmos DB that please assign me 5000 RUs per second. Now this is called your provision throughput. You are provisioning the throughput, right? Cosmos DB is just provisioning you 5000 RUs, based on your decision. So guaranteed you will have 5000 RUs for you, how much ever your data, data throughput might be. So, but in case, let's say, at some point of time, the data throughput is not that much. So in that case, since you have defined 5000 RUs already, you will be left with a lot of unused capacity because you will be paying for 5000 RUs, but you are not utilizing for 5000 RUs, right? So that is something called as your provisioned throughput. Now the concept of serverless throughput is basically, in this case, you only pay for the throughput or the data processing that you do. That's all. So if your query is requiring only one RU, then you are only paying for one RU. If your query is requiring for 5 RUs, then you are paying for 5 RUs. So that is called the concept of your serverless and your provision throughput. So right now I'll choose provision throughput for this demo. And now let's go to the next option. Then the next option is global distribution. I've already explained in detail about the geo redundancy, right? In my previous video, you can definitely go ahead and watch that in the Azure Basics play series. Now this geo redundancy, for now I'll disable it because I do not want to have any geo redundancy right now. Multi-region writes is essentially same as geo redundancy, where your data is replicated across multiple regions and you are able to write to multiple regions. So that is called a multi-region writes. Now networking I'll leave as it is. Backup policy also I'll leave it as it is. It just define the how you want to retrieve your data, what will be the retention period and all. Encryption is something Anyway, whatever data you have, that is already encrypted by Azure, but sometimes you want to double encrypt your data. In that case, you have to provide your own encryption key. This option is essentially for that, but not much required anyway. Now you can go ahead and click on review and create. If it validates, you can go ahead and click on create. So guys, basically creation takes a lot of time. So I already have an account of Cosmos DB. So I'm going to typically show you this one. Now, if you see on the left hand side, there are a lot of options over here. The one which I'm going to discuss right now is default consistency. So now when you talk about default consistency, the number of RUs depends on default consistency as well. So right now by default, session is the default consistency. Now when I talk about consistency, what does it exactly mean, right? So I'll go back to the PPT. So there are basically five consistency levels. So the first and the strongest one is the strong one, and the weaker one is the eventual one. So when I say strong one, it essentially means that if I am writing the data in, let's say, Europe region, and someone is reading the data from Asia Pacific region, then that person can essentially read the same data in the same order at the same time, right? That is called the strongest level of consistency. And actually I'll go in detail about each and every consistency level. So let's go back to the portal and I'll show you how it is defined. So if you see over here, if you click on the strong, let me zoom it. Now guys, you can see over here this visual is appearing. What happens over here is, if someone is writing in East US region, right? If someone is writing in East US region and other people are trying to read the same data from the other regions, they can read it at the same time without any order change. So if I'm writing the data in a particular order, the other person will be able to read the data in the same order. That is called your strong consistency. Now the second one is bounded staleness. So if I click on this bounded staleness, you actually, if you see on the top, you have to define the time lag over here. So now what happens is, I'll quickly zoom in this visual again. This is a very nice visual. Let me put it in the screen in the right way. Now I guess you'll be able to see. So if you see here, if a person is writing in East US 2, in the same region, a person will be able to read the data in the same order at the same time. But when you talk about other region reads, so if a person is reading from some other region, then they will have then they will have a lag, they will have a delay. Now this delay however will actually be just in milliseconds, and that you actually have to define at the top, that what delay it would be. At the top you actually define what the delay would be. So this is called as bounded staleness, and the default one is session. So when you talk about session, again I'll zoom it for you. Now it is basically a session level property. So if I'm writing in East US 2 region in a session A, so if anybody in any region tries to read from that session, they will actually see the same order of the data and they can see it at the same time. But the moment a person changes the session, if the person is reading in session B, then in that case the person will see the lag. The person will see the data after a certain milliseconds, right? So that is called your session level consistency. The fourth one is consistent prefix. So now if you see this consistent prefix, again I will zoom it. So this basically, if a person is writing and you are trying to read the data, definitely it will have some level of latency involved. So each region will have different level of latency. So if I'm writing to East US 2 and someone is reading from East US 2 from the same region, if someone is trying to read, and even from the other region if someone is trying to read, they will have different level of latencies. They will see the lag in the data reads. However, the order will remain the same. And similarly, the last one is the eventual. So in fact, I'll zoom it and I want you to, see this visual and try to understand what does it mean, and write in the comment section what do you infer from this visual. What does eventual consistency mean? So I'll pause here and you can actually see it once again. You can pause the video over here, try to see the visual, understand it, and write in the comment section what you feel eventual consistency means. So now guys, let's move ahead. I'll go back to the session because session is the default one. And now let's go to the overview and data explorer. So data, you can have storage explorer as well. I've not made any video on storage explorer, but if you have a storage explorer, well and good. That is the, the best one. But in case you don't have, we can always go ahead with this data explorer option over here. So the very first thing that you do in the portal is that you create a new container over here. You see an option over here. Before that, it is all blank. So first you need to create a new container, and that is your database. So when I say database, you can see, you can think of Azure Cosmos DB as something like SQL Server, and you have to create a database inside it. So now let's create a database named as Bhavna Demo, and this name again has to be globally unique, and then you have to configure the rest of the settings. So the other setting that you see of share throughput across containers, to actually explain that, I'll actually show you this. So in Cosmos DB, you create different databases, right? So right now we are creating one databases. Now inside databases, you have different collections. So when I say collection, collections are nothing just the tables. So now when you're talking about the throughput, whether you want to specify it at the database level or at the tables level. So this is what this property mean, and right now it is definitely, all most of the time it is better to create a throughput across the database rather than creating it on the table. So I'll check this option, and database throughput manual or auto scale. So if I click on manual, so the minimum required throughput is 400 RUs per second, which I've already explained. So if you want to go with, let's keep it as manual as 400 RUs. Now container ID is nothing, it is just the name of your table, and partition key is just like your regular partition key which you have in let's say in your Spark or something. But remember that here partitions are very different. So when I say partitions are different, whenever you create a partition in Spark, what happens is your related data goes in one partition, but that's not the case with Cosmos DB. But this is something that happens underneath. You do not have to concentrate much on that, but just remember that the partitions in Cosmos DBs are not straightforward. Like let's say you partition something based on a city, that doesn't necessarily mean that all the data related to one city might go to one partition. It's not like that. So but yeah, you should always keep the partition key as something which you would query on. So this thing you need to remember for sure. So now let's name my table, which is the container, as person, and let's keep the partition key as ID itself. And okay, let's not keep it as ID. To explain you in a better way, I'd use, so it is taking little time to create a container which is a table named as person with the partition key of last name. So guys, here we are. Now you can see the database Bhavna demo which we created and the container named as person. Let's go to the items, and you can see we do not have anything over here. Let's click on the new item and let's try to create something here. So let's say my first name as, let's write it as Bhavna, right? And after that, I'm just trying to create a JSON, and again let's try to name my last name as baby, right? So this is something that I have. Let's try to save it. Now you will see the once I have saved it, what happened is this has appeared. What is this? Now I have an ID over here. Now since I have not defined my partition based on ID, Cosmos DB will automatically create ID over here, and by default it will create these metadata as well. So I hope it is very clear now how it defines your ID. It has, by default it has automatically defined the ID and the metadata as well. And similarly, let's create a one more item. Now again, now in this case, I'll specify the ID as 123. Then again, I'll try to create first name as, again, I'll try to write as Bhavna over here, Bhavna 2, and then I'll write my last name again as baby 2. Right? So this is again a JSON that I have created, and now let's go ahead and save it. Again, what will happen is it will it will, you can see that it has already created the tags, the e tag, the attachment, the timestamp. It has already created the metadata as well over here, and now you can see these items over here. I have both these items. If I click on 123, I can see the JSON over here. I can see the JSON for the first one as well. So now once you have these two records, you can actually go at the top. I think here, select new SQL query. Now here you can directly use select star from C, and you can write anything. So this is where you can write your SQL, and you can try to fetch the data that you have. So let me zoom it out, and in fact you can write over here. Let's write C dot first name from C, and then let's try to execute the query. So in fact, you can remove these curly braces from here and then try to just execute this query. Then you will see the first name coming in over here. Now, apart from this, I also have, a very good, I actually have the script. So I'll try to run those scripts directly, and I'll try to show you the query data. Now in the items, I'll actually copy this. So this you can actually get from the Microsoft's document directly. So now you can see how the data will look like. Now instead of this, let's try to copy this. So guys, you can actually see the ID and how the parents is actually a list over here, and similarly your children. So remember that it is a NoSQL database, so there is no structure defined. You can write any structure whichever way you want. And now let's try to update it, and this is your item. In fact, you need to discard it first and then create a new item, and then let's place it over here. So now this is a direct copy and paste script which you can get from the Microsoft documentation, and let's try to save it. Now once you save it, you can actually see this record coming over here, right? So now you have all the three records over here. So now let's go ahead and do the select operation from here, and now let's just simply try to create a new SQL query and just run this query. So guys, now you can see once I have run this query, select star from family where ID equal to this family. Now you can see that I have got the exact data over here, right? And similarly, if you want to go bit, little, if you want to do little joins or things like that, then again you have this query, and then you can simply join in and try to retrieve the exact field which you want to retrieve. And similarly, like, you can go deeper and deeper inside the queries, and to find you can go inside the deeper queries for the JSON, and you can try to fetch, like for example here I'm trying to fetch city, right? I'm trying to go deeper inside my JSON. I'm trying to fetch city from the address. If I go back over here, now you can see that inside address I have city, right? So inside this address I'm going deeper, and I'm trying to get city out of it, right? So in the similar way, you can try out multiple queries. These are already available on the Microsoft Docs as well. You can go ahead and you can try out. And I think this has been quite a long session. So I hope you all were able to understand what I'm trying to explain in this video. In case you have any comments and you have any doubts, do let me know in the comment sections. And similarly, I'll try to cover more details about Azure Cosmos DB in my upcoming videos, but I have given a very huge overview about Cosmos DB in this video itself. That's why it was pretty long. So do remember to like, share and subscribe to my channel, and thank you for being till here. Thank you so much.